Today in pre-cal we talked about trig at any angle, so what to do if the radius is not 1, basically. The first example is if I have the point -3, 4, and I want to find all 6 trig functions. I'm going to start by thinking about what quadrant this point would be in, and that would be the second quadrant. So I'm going to draw a triangle in the second quadrant. My x-coordinate would be -3, and my y-coordinate would be 4. And then I can use the Pythagorean theorem to find this third side. So I have -3 squared plus 4 squared equals c squared. -3 squared is 9, 4 squared is 16, and if I combine those I have 25. So my third side is 5, my radius. Okay, now to find my 6 trig functions, I have sine, cosine, tangent, cosecant, secant, and cotangent. I need to be sure I line those up so that when I go to flip them in a minute, that'll be a little bit easier. For sine, here's my angle, so opposite over hypotenuse, 4 over 5. Cosine, adjacent over hypotenuse, -3 over 5. Tangent is opposite over adjacent, so 4 over -3. And then if I go to flip each one of those, it would be 5 over 4, 5 over -3, -3 over 4. And I could always check those out. For instance, secant is hypotenuse over adjacent, that does check. The next type that we looked at in class was if you're given one of the 6 trig functions, in this case the tangent of theta is -5 over 4, the cosine of theta is greater than 0, and we want to find the sine and the secant of theta. To do that, again, we need to draw a triangle. Before we can do that, we need to use these conditions. If the cosine is greater than 0, remember cosine is the x value, so x is greater than 0. That happens in quadrants 1 and 4. And tangent is y over x. So this is my y value, which tells me I'm in quadrant number 4. And 4 is my x value. I use Pythagorean theorem to catch that third side again. And so my third side is the square root of 41. Now, if that one is something that can be reduced or simplified, you'll need to do that. In this case, it can't be because 41 is a prime number. Now that we have all 3 sides, we can find our sine and our secant. Sine is opposite over hypotenuse, which is -5 over the square root of 41. This interior angle is always our angle no matter what, so don't let that confuse you. That's always where you're going to choose your theta to be. And if I simplify that, I get -5 square root of 41 over 41. And for secant, secant is the opposite of cosine, so it is the hypotenuse over the adjacent, which is square root of 41 over 4. And that's it for example 2. The third example is kind of more of a deductive reasoning theoretical example, and that is if I'm told that the cosine of theta is greater than 0 and the cosecant of theta is less than 0, and I want you to name the quadrant. So where would that be located? To do that, I need to know the relationships of cosine and cosecant. Cosine is our x value is greater than 0. X is greater than 0 in quadrants 1 and 4. If you're more of a visual person, you might want to shade those 2 in. Cosecant is the opposite of 1 over sine, or 1 over y, is less than 0. If that's to be the case, something less than 0 is negative, so y would have to be negative, and that happens in quadrants 3 and 4. And so the cross-section where both things happen are in quadrant 4. The assignment is A2, and that's page 318. Numbers 3 to 8 and 11 to 16.